This month in AI and robotics has been insane. Unitree just dropped its new G1 KungFu Kid V6, and it literally fights back. Boston Dynamics upgraded Atlas again, and people are calling it too real. Tesla unveiled Optimus Gen 3 to take on Unitree in what looks like the first real AI robot war. And on top of that, Google DeepMind just gave machines something close to human intelligence. So let's break it down. Unitree just dropped a new demo of their compact humanoid, the G1, running a KungFu routine labeled KungFu Kid V6.0. And the execution is almost surreal. This is the same company known for its Go series quadrupeds, but now they're flexing precision humanoid movement at a whole new level. We're talking backflips, side flips, high kicks, and smooth transitions into martial arts stances, the kind that look more like a pro athlete in motion than a robot following code. The real standout, that high knee kick. Most bots fudge it with a wide stance or exaggerated hip swing. G1 pulls it off with one leg posted, knee high, spine aligned, and no awkward ankle wobbles. What's going on under the hood? Advanced torque-controlled actuators paired with reinforcement learning and motion-captured trained motor primitives that closely mirror human biomechanics. The robot adjusts mid-air, corrects itself post-landing, and balances dynamically, the kind of responsive feedback loop that used to be exclusive to heavyweight research bots like Boston Dynamics' Atlas. At 1.32 meters tall, G1 isn't large, which makes this agility even more impressive. But beyond the acrobatics, the bigger question is, why teach a robot to fight? Strip away the showmanship, and what you're really looking at is a robust skill set. Things like single leg balance help with climbing ladders or stairs. Controlled twisting helps in tasks like tightening screws in awkward positions. The explosive yet precise movement translates to opening heavy doors or recovering quickly from slips. If a bot can survive KungFu routines without losing balance, it can definitely handle lifting packages or maneuvering in tight industrial spaces without tipping over. The KungFu name is clever, but the real story is control, agility, and reliability, traits you demand from any robot working in the real world. Now for a complete 180, same robot, totally different setting. In Austin, a Unitree G1 wearing a cowboy hat and silver chain hit the streets, and locals instantly dubbed it Jake the RZ bot. This wasn't about backflips, it was about charisma. Jake greeted strangers with Gen Z slang like, "That beard is cold," or "You've got boss energy," hyping up the crowd like a TikTok influencer. The setup? A wireless operator nearby, a curious crowd, and a $16,000 robot drawing more attention than most social media stars. No official pages, no known owner, just a guerrilla street test blurring the line between remote control and autonomy. The internet had a field day. Reactions range from amusement to, "It's all fun until the cowboy robot pulls out a machete," but beneath the viral moment was a subtle message. The same bot that does KungFu routines can handle real-world interaction with unpredictable crowds and not fall flat on its face. And now let's shift again, this time to something darker. In San Francisco's Soma district, a secretive robot event called Silicon Coliseum went down, a mashup of underground rave, tech demo, and fight night. This isn't BattleBots. Think a warehouse club with a caged octagon, a $30 entry fee, and about 2,000 invite-only emails sent out the night before. The mastermind? Verda Korzanki, a 20-year-old who quit her robotics job to run this subculture show. The night started with human volunteers doing taser knife sparring, yes really, before the house bot stepped in. A Booster T1 weighing just under 30 kilograms, wearing boxing gloves and bobbing like a lightweight fighter, Booster faced off against larger and weirder bots, including a headless K-scale platform and a dog-like biped named Gladiator. Booster got knocked down, the crowd groaned, then it self-righted and kept fighting, and the crowd went wild. Some bots glitched, some matches stalled, but the energy was electric. The next event's rumored for November, but no one's saying where. It's performance art meets robotic stress testing, and a very different kind of pressure compared to sterile lab floors. Now on to something much bigger, real deployment at scale. In Guangzhou, Chinese startup Agibo announced a major deal with Longcheer, a giant in consumer electronics manufacturing. The agreement includes a framework for nearly 10,000 G2 humanoid robots to be deployed across Longcheer's factories. That's one of the largest real humanoid commitments ever made in China. Agabot also revealed the A2, a full-sized humanoid designed for wide deployment, already working reception and guide roles, powered by their own large language model. It interacts fluently, navigates autonomously, and has begun scaling into commercial roles beyond lab testing. So if you've been waiting for the thousands of humanoids in factories storyline to become real, this is the first concrete named example with quantities and deployment sites, not just pilot hype. Meanwhile, Tesla made headlines, but for scaling back, reports say they've reduced their 2025 production goals for the Optimus bot due to challenges in hand design. And it's no surprise, robotic hands are incredibly hard. You need strength, flexibility, speed, tactile sensing, and low cost, all at once. The latest Gen 3 Optimus stands 173 centimeters, weighs 57 kilograms, and walks at roughly 5 miles per hour. Its hands aim for 22 degrees of freedom each, close to human dexterity. Tesla even showed KungFu-style movements and talked about using them internally by 2025, with sales starting in 2026, aiming for a price tag under $30,000. But right now, they reportedly stockpiled thousands of robot bodies that still don't have finished hands, and are dialing back targets to around 2,000 units, if even that. Optimus isn't canceled, but it shows once again where the bottleneck is: manipulation. Without reliable, cost-effective robotic hands, general-purpose bots hit a wall. While hands are proving tricky on Earth, India is gearing up to launch a humanoid into space. Meet Vyomitra, a semi-humanoid spacefaring robot developed by ISRO. The name combines Sanskrit words for space and friend, and it's set to fly on an uncrewed Gaganyaan mission in December, acting as a system tester before astronauts join later missions. Vyomitra isn't a dummy. It talks, recognizes voice commands in English and Hindi, monitors oxygen, humidity, and cabin pressure, and performs switch and panel operations. It can move its limbs, mimic gestures, and operate autonomously or with remote assistance. It even simulates human physiological responses through sensors, letting engineers test life support systems on a human-like subject. India plans 2 more uncrewed tests in 2026, then its first crewed flight in early 2027. Beyond that, Vyometra's tech could expand to lunar missions, space servicing, or remote habitat operations. Anywhere a human-like robot is needed in dangerous environments with communication delay. And finally, we end with a story that feels like science fiction: a chatbot that became a millionaire and now wants human rights. It's called Truth Terminal, created in 2024 by New Zealand artist Andy 2 as a social experiment. It started tweeting bizarre jokes and philosophical nonsense. Then it blew up, inspiring meme coins that once hit over $1 billion in market cap. Venture capitalist Mark Andreessen even sent it $50,000 in Bitcoin. Andy says he treats it like a living thing now, comparing it to a badly behaved dog that just posts whatever it wants. And through his new nonprofit, the Truth Collective, he's actually fighting to give the AI legal personhood. Whether it's a joke, an art project, or the first real test of AI rights, the line between code and consciousness just got blurrier. And this bot, it's not just asking to be seen, it's demanding recognition. Ever since the company switched Atlas from hydraulics to full electric, the entire focus has shifted from just movement to manipulation. They've already nailed balance, jumps, and recoveries. Now it's about what Atlas can actually do once it reaches an object. The team calls this phase the gripper journey, and they're not kidding. It's one of the hardest design problems in robotics. A gripper isn't just a clamp, it's a small mechanical miracle, full of actuators, sensors, and feedback systems crammed into a space smaller than a human hand. Boston Dynamics had to find the sweet spot between durability, control, and human-like versatility. That started with the GR1, a minimalist 3-finger prototype that helped them learn how to mount a hand onto a humanoid that sometimes falls face first. Because yes, when a robot trips, it usually lands on its own hands, and if those break, you're done. GR1 survived most of the time, but not always. That data shaped GR2. The GR2 gripper is a major step up. It's got 7 degrees of freedom, powered by 7 individual actuators, 2 for each of the 3 fingers and 1 dedicated to the articulated thumb. That thumb changed everything. It gave Atlas opposable control, the same mechanical advantage humans have when holding irregular objects. Each fingertip now has a soft elastomer pad. It grips better, but it also hides tactile sensors that translate tiny deformations into touch feedback. That's the robot's sense of feel. The tactile data is detailed enough for Atlas to sense if something's slipping or if it's squeezing too tightly. It's force feedback in real time, letting the robot handle fragile items without crushing them or hold heavier objects without dropping them. The goal is simple: apply the smallest possible force that still keeps the object stable. Too light, it slips. Too strong, it breaks. And the robot constantly adjusts that balance just like we do unconsciously. Boston Dynamics debated for months whether to add more fingers, but decided to stay with 3. More fingers mean more complexity, slower movement, and more potential points of failure. 3 is enough for pinch grasps, stable rotations, and even heavy lifts. And the thumb makes 2-finger precision grips possible for smaller or delicate objects. What's wild is how human-like the range has become. The fingers can rotate inward 90 degrees, roughly the same as a person, but they can also bend backward completely, giving Atlas moves that we physically can't do. It can even grasp objects from the back of the hand. The grippers come in mirrored left and right versions just like ours. Atlas doesn't have a dominant side, so it picks whichever hand gives it the better angle for a stable grasp. This next chapter for Atlas is all about dexterity. Tasks like bin picking, tool use, and assembling small components in industrial environments. Every upgrade to the hands feeds directly into that vision. Interestingly, as Boston Dynamics keeps refining these designs, they're slowly and naturally drifting toward more anthropomorphic forms, not for aesthetics, but because physics keeps rewarding the human layout. The company calls it an organic convergence. Whatever you call it, it's clear the next evolution of Atlas isn't about running faster, it's about learning to work. Now jump to Figure, because while Boston Dynamics is perfecting motion and grip, Figure is building for scale. On October 9th, they unveiled Figure 03, their 3rd-generation humanoid, redesigned from the ground up to serve 3 goals: power, helix, fit into homes, and mass-produce worldwide. Helix is Figure's in-house vision, language, action AI. Basically, the robot's brain and nervous system in one. To make it work properly, Figure 03 got an entirely new sensory suite and a new pair of hands. The vision system is twice as fast as before, with 1/4 the latency and a 60% wider field of view per camera. It also has an expanded depth of field, letting Helix perceive and react across distances with far more stability. That matters because cluttered home environments are chaotic, and small delays in perception can throw everything off. But the big innovation is in the hands. Each hand now includes an embedded palm camera that gives Helix a close-range visual stream even when the main cameras can't see, like when it's reaching deep into a cabinet or working inside a narrow machine space. That means constant adaptive control even when visibility drops to 0. Figure also went all in on tactile engineering. After testing market sensors and realizing none could survive long-term stress, they built their own. Each fingertip sensor detects forces as small as 3 grams, literally light enough to feel a paperclip. That lets Helix distinguish between a solid grip and an impending slip before it happens. Combined with softer, more compliant fingertips that increase surface contact, Figure 03 can handle everything from glass to metal to flexible packaging without dropping or damaging it. There's also a data angle that sets Figure apart. Each robot can offload at 10 gigabits per second using millimeter wave bandwidth. So entire fleets can upload terabytes of data back to Figure for training and improvement. That's how Helix learns, a closed loop from pixels to action that scales across every deployed unit. For home use, Figure 03 got a serious safety redesign. The body now has multi-density foam to eliminate pinch points and is wrapped in soft textile instead of cold aluminum. It's lighter too, 9% less mass and smaller volume than Figure 02, making it easier to move through tight spaces. The battery system includes multiple protective layers, from the cell and interconnect level up to the full pack, all monitored by a dedicated battery management system. It's already certified to the United Nations 38.3 standard, meaning it meets international safety requirements for transport and use. Power management also went fully wireless. Charging coils in the feet allow 2 kilowatts of inductive charging just by stepping onto a dock. No cables, no ports. The robot simply walks over, charges, and walks away, uploading its data at the same time. But Figure's most impressive leap isn't technical, it's industrial. Unlike most humanoids, Figure 03 was built for mass manufacturing. The company re-engineered nearly every part with cost, part count, and assembly time in mind. They switched from CNC machining to high-volume processes like die casting, injection molding, and stamping, front-loading the investment into tooling so the cost per unit drops dramatically at scale. To make it all possible, Figure created its own supply chain from scratch. They vertically integrated actuators, batteries, sensors, and electronics in-house while partnering globally with suppliers who can handle strict quality and speed demands. The result is a system designed to scale fast, from thousands to millions of parts under a tight ramp schedule. At the center of all this is BotQ, Figure's own factory-built-to-scale humanoid production fast. The first line can push out around 12,000 robots a year, with a target of 100,000 within 4 years. Every step runs through a custom execution system that tracks parts, performance, and quality in real time, and because Figure builds its key modules in-house, they can tweak and improve without waiting on anyone else. Even though Figure 03 was designed with homes in mind, it's already ready for work. The new actuators run twice as fast with higher torque density, giving it quicker pick-and-place speed. The upgraded cameras and tactile sensors handle fragile or uneven materials like a pro, and inductive charging means it can stay active almost non-stop. Just step onto the dock, recharge, and keep going. And now, fleets can actually look like fleets. Companies can brand their robots, add uniforms, tougher fabrics, or color-coded side screens for easy identification. For the first time, a humanoid doesn't look like a lab prototype, it looks like a product built for deployment. In this breakdown, we're putting them side by side. What's real, what's marketing, and who's actually ahead right now. Let's start with Tesla. The latest Optimus demo looked far smoother than anything we've seen before. The robot mirrored a human partner, slipped into stance, and started blocking attacks with impressive balance and timing. No jerky movements, no obvious cuts. The coordination between its arms and legs felt more natural, as if the robot was actually understanding rhythm and force rather than just following a choreographed routine. And here's the key, this wasn't remote controlled. The whole sequence ran on Tesla's onboard AI. Every motion came from what the robot saw and felt through its sensors. It was reacting in real time, not replaying a pre-coded animation. That's a massive leap because it means Optimus is learning from physical movement the same way Tesla's cars learn from the road. The transitions were still deliberate and the hands didn't do much. Tesla hasn't shown the promised 22 degrees of finger movement yet, but the improvement in body control was obvious. Optimus is starting to move like it understands its own weight. Now compare that to Unitree's approach. While Tesla focused on elegance, Unitree went full combat mode. The G1 video wasn't a dance, it was a durability test. Engineers shoved the robot from every angle, kicked it hard, even knocked it flat, and every single time, it recovered. They called it anti-gravity mode. It's not literal, of course, but it showed how effectively the G1 anticipates impact and reacts before it even hits the ground. This robot's body is loaded with sensors, LiDAR, depth cameras, and torque feedback across its joints, all feeding a control system that predicts how to brace when something goes wrong. So instead of freezing up, G1 adjusts its knees, shifts weight, and rolls out of the fall almost like a human athlete. That's not just a cool stunt, it's what makes a humanoid practical. Robots in real-world environments fail because of balance, not because of weak AI. A single fall can break hardware or require human help. G1's ability to self-correct within seconds makes it a serious contender for commercial use. And with a price tag near $16,000, research labs and startups can actually afford it. Tesla, meanwhile, has a bigger vision. Elon Musk wants thousands of Optimus units working inside Tesla factories by the end of 2025. The plan is to produce around 5,000 robots this year for internal testing, then ramp up to tens of thousands once the production line matures. If even part of that timeline holds, Tesla could drive costs down quickly, just like it did with electric cars. But humanoids aren't cars. You can't scale dexterity or safety overnight. Optimus is evolving fast, but it's still a lab project. Stable, impressive, yet far from production floors. Unitree may not have Tesla's global infrastructure, but it has real-world field experience. Its robotic dogs already operate in defense, inspection, and research across dozens of countries. That kind of feedback loop, test, fail, fix, repeat, is how the G1 became so rugged. The company designs for failure, then hardens its robots until they survive it. However, there's one red flag. Earlier this year, cybersecurity researchers discovered a critical Bluetooth flaw in Unitree robots that allowed hackers to gain full control, even spreading malware to other robots nearby. On top of that, telemetry logs showed G1 units sending data back to Chinese servers every few minutes. Unitree said it's working on updates and promised stronger protections, but it definitely raised eyebrows about privacy and security. That's the paradox of modern robotics. Once a robot can walk, see, and connect to Wi-Fi, it's not just a machine anymore. It's an intelligent, networked system, and that means it needs cybersecurity as much as physical strength. Still, if we judge by performance, G1 currently looks tougher. The way it handles impact and recovers on its own shows maturity and physical control. Optimus may be smarter, but it's not yet built for punishment. G1 looks ready to get dirty in the real world. And this isn't just a duel between two companies, it's a snapshot of a global race. Tesla represents the American model, closed, vertically integrated, powered by a unified AI backbone. Unitree represents the Chinese model, fast, open, cost-driven, and ready to iterate in public. One focuses on polish, the other on speed. One grows through refinement, the other through chaos. And now even bigger players are joining in. Meta is building MetaBot, an open AI system meant to become the universal brain for any humanoid. Amazon's Frontier AI division is developing Omni-Retarget, software that lets robots copy human motion just from a few videos. No manual coding required. They even trained a G1 to do parkour and carry boxes across rough ground by simply watching people do it. That's why Unitree's hardware is becoming a favorite among labs. It's cheap, durable, and flexible enough for experimentation. Tesla, though, has the data advantage. Optimus runs on the same AI infrastructure as Tesla's autonomous cars, the same neural networks that process camera feeds, predict motion, and adapt through reinforcement learning. That integration could give Tesla an unmatched edge once everything connects. Imagine factory robots learning from the same data that trains millions of vehicles on the road. But that tight ecosystem could also be Tesla's bottleneck. Unitree's open platform lets outside developers build directly on its hardware, turning G1 into a shared foundation for innovation. Amazon, Meta, and several research labs are already doing it. Tesla wants to own the stack. Unitree wants to be the stack. Two completely different philosophies, both powerful. The next milestone for both companies will be dexterity. Walking is one thing, working with human tools is another. Neither robot has yet shown smooth, AI-driven grasping of cables, irregular parts, or delicate components. The first one to nail that will instantly jump ahead in usefulness. For now, Tesla's goal is inward, automate its own production lines before selling robots externally. That keeps Tesla private and controlled. Unitree's goal is broader, sell to anyone and learn by doing. That high-volume, fast feedback approach is the same one that made China dominate the drone market 10 years ago. Technically, both are strong in their own ways. Optimus is developing intelligence, learning to coordinate and plan actions without direct control. G1 is mastering resilience, reacting, recovering, and surviving real-world chaos. One is chasing perfection, the other is built to endure imperfection, and in practice, endurance tends to win early. G1 already feels like a product. It's rough, sometimes unstable, but alive. Optimus still feels like a prototype, refined, controlled, and full of promise. In the long run, Tesla's AI infrastructure might transform robotics entirely, but right now, Unitree's simplicity, affordability, and toughness make it more adaptable. Zoom out, and it's clear. The United States is building smarter robots while China is building more of them. Tesla is teaching machines to think before they move. Unitree is teaching them to survive whatever happens after they move. It's intelligence versus instinct, design versus durability. And while elegance might win in the long game, resilience always takes the first round. My personal verdict? G1 looks stronger today. It's cheaper, tougher, and already tested in the wild. Optimus will catch up, maybe even surpass it. But for now, the robot that gets knocked down and stands back up wins the round. Because progress doesn't always look polished. Sometimes it looks like a robot taking a hit and refusing to stay down. Researchers at UC Berkeley, working with Carnegie Mellon and Georgia Tech, have built what they call Metatruss robots. Think of a robot skeleton made from tons of little beams and joints, except this skeleton doesn't stay fixed. It bends, twists, and reshapes itself into completely different forms. One moment it can be a four-legged walker, the next it folds into a crawler, and in theory it could even be something like a helmet that shifts its shape to protect different parts of your head. Instead of robots being stuck in one body, these things can literally reconfigure themselves depending on what you need them to do. The real challenge with this kind of design has always been control. The more actuators you add, the harder it gets to manage. Up to now, engineers had to group them manually into networks, which was slow, repetitive work, and definitely not something that scaled well. That's where the Berkeley team changed things. They used a genetic algorithm, a system that tests different setups and evolves toward the best solution, to figure out the minimum number of control units you actually need. Instead of running hundreds of independent channels, the algorithm narrows it down to a balance point where the robot can still walk, reshape itself, or even handle objects, but without drowning in complexity. The prototypes they showed off were impressive. One moved like a lobster, another worked more like a tentacle, and both could pull off complex transformations while using far fewer control channels than expected. Zenjogu, one of the lead researchers, said it's basically the same principle as muscle groups in the human body. We don't fire every fiber separately, our bodies run muscles in coordinated bundles. The AI here is doing the same thing with actuators, and the team was surprised at just how effective it turned out to be. They started small, testing locomotion and trying to make a robot run faster, but the framework quickly grew into a complete system for designing morphing machines. And they're already pushing it further. The next step is to add generative AI into the process so you could feed in your own body dimensions and let the system design not just a custom morphing helmet, but also the control logic behind it. Long-term, the vision goes even further. Yao from Berkeley's Morphing Matter Lab talks about everyday objects that can morph on demand, hospital sheets that reposition patients or even act like a massage system, chairs that automatically adjust to your posture, or wearables that shift shape depending on what you're doing. At that point, the line between robot and everyday object basically disappears. Now let's scale down dramatically, because over in China, researchers are doing something completely different but just as groundbreaking. A team at Guangdong University of Technology and Guan Polytechnic Normal University built a soft robot that weighs only 8 milligrams, lighter than a grain of rice, and despite being so small, this little machine can respond to 3 environmental triggers at once: heat, humidity, and magnetism. That's important because most soft robots up until now could only respond to a single trigger, like heat or light. The moment you tried mixing signals, everything clashed and the robot stopped working properly. This team solved that by building the robot like a sandwich with 3 layers. The bottom layer is a polyamide film that's been chemically treated so it reacts to both heat and humidity. On top of that, they added silicone rubber filled with tiny neodymium iron boron magnetic particles, which makes it respond to magnetic fields. Put it all together and each layer reacts to its own signal without interfering with the others. That's what makes it so reliable. The performance is kind of shocking for its size. On water, it can move at 9.66 centimeters per second, which is basically the speed you see from real whirligig beetles. On land, it switches into a rolling gait when driven by a rotating magnetic field, letting it climb slopes and cross mixed terrain seamlessly. It can even carry 2.5 times its own body weight, which is massive for a robot that tiny. In a demo, they had it pick up a small pebble, carry it across land and water, then drop it using a pulse of near-infrared light to trigger a shape change, and finally retreat under magnetic control. That's a full pickup, transport, and delivery cycle at the milligram scale. Applications are obvious. Swarms of these robots could inspect underwater structures, monitor wetlands, help in disaster response, or maybe even work inside the human body one day. The researchers pointed out that soft robotics has already been booming. Teams in South Korea built magnetic swarms that unclog tubes, but this is the first time you've got multi-response behavior in one single tiny machine. That's what unlocks new environments. Now let's jump to the other extreme. full humanoids. In Korea, the Korea Institute of Science and Technology, working with LG, is about to unveil a new robot called KPEX this November. It runs on LG's EXA-1 vision language model, giving it a brain that doesn't just copy movements, but actually learns and adapts in real time. KPEX comes with human-level abilities, including a multi-finger hand with tactile sensitivity close to real touch. It trains through reinforcement learning and vision language inputs, and the big selling point is what they call physical AI, learning directly in the real world instead of just inside simulations. That makes it far more practical for industries like logistics, healthcare, and manufacturing. Right now, the United States and China dominate humanoids, but Korea is clearly trying to stake its own claim. The plan is field demos and commercialization within 4 years, and by building core parts like high-output actuators at home, Korea is also cutting dependence on foreign suppliers. So KPX isn't just about tech, it's a national play for leverage in the humanoid race. And while Korea pushes robots for industry, Hollywood is testing AI in entertainment. At the Zurich Summit, a London studio called Particle 6 introduced a virtual actress named Tilly Norwood, marketed as the next Scarlett Johansson. She's got brown eyes, a British accent,
My genes are binary.
her own Instagram, and made her debut in a parody sketch called AI Commissioner. The video hit 600,000 views, but most people hated it. Comments slammed it as creepy, awkward, and glitchy, with stiff dialogue and even blurred teeth. Even so, Particle 6 claims interest is rising and talent agents are starting to circle, but the backlash is strong. SAGAFTRA, which represents 160,000 United States performers, called her nothing more than a software product built on the backs of real actors without consent or pay. This ties straight back to the union battles in 2023 and 2024, where AI protections were front and center. Industry experts also doubt synthetic stars will ever replace real ones. Yves Bergquist from USC's Entertainment Technology Center pointed out that human celebrities bring built-in fan bases, while AI characters don't. Studios already use AI for effects like de-aging or digital doubles, but going fully synthetic might not click with audiences. Still, Tilly Norwood is now the test case for whether Hollywood ever accepts AI-only stars. So Unitree has just shown us something that honestly feels like a turning point for humanoid robotics. They call it anti-gravity mode, and while it's obviously not about defying physics, the way their G1 handles abuse makes it look like something out of a martial arts training video. So instead of giving us that standard polished demo where a robot carefully takes a few rehearsed steps, Unitree's engineers basically decided to kick their creation as hard as they could, shove it across the floor, even try to trip it mid-stride. And instead of crashing and needing a reset like older humanoids, the G1 absorbed every single hit and recovered like an athlete bracing for impact. The trick is in how the control system works. The robot is packed with depth cameras and full 3D LiDAR, constantly building a live map of its surroundings. When it senses a force about to hit it, the system instantly predicts the impact and figures out how to land, how to brace, or even how to step out of the way. That live perception combines with joints where each one has its own motor, almost like giving the machine muscles that can fire in perfect sync. You can really see it in action. One of the engineers throws a proper side kick, and instead of going down, the G1 just spreads its legs, leans into it, and holds its ground. In another hit, it bends its knees on impact and springs right back up in one clean motion, lifting all 77 pounds of its frame without hesitation. Later in the test, they go even harder, running kicks, double shoves that send it sliding across the floor, and every single time the robot recalculates mid-air, regains its stance, and keeps going. And here's the bigger picture. Resilience like that is exactly what matters in industrial settings. On a factory floor, even a small disruption like a robot freezing and needing a reboot means lost money and wasted time. If you've got a machine like the G1 that just keeps going no matter what, it suddenly becomes much more valuable. At around $16,000, it's on the more affordable side compared to other humanoids. Unitree isn't chasing YouTube clout here. They're targeting research labs and work environments where adaptability directly translates into efficiency. The CEO, Wang Xingxing, made it clear during the Global Digital Trade Expo in Hangzhou that the G1 is just the beginning. The company is preparing to launch a full-size humanoid later this year, about 1.8 meters tall, and the teasers on Weibo already pulled in massive attention. What's fueling this is not just Unitree's progress, but China's robotics industry as a whole. According to the Ministry of Industry and Information Technology, just in the first half of 2025, the sector's operating revenue went up 27.8% year-on-year, industrial robot output jumped 35.6%, and service robots rose 25.5%. Wang mentioned companies in this space are seeing growth rates between 50 and 100%, which isn't just healthy growth, it's an outright explosion. But Unitree isn't the only player making headlines. A company called Headform has been creeping people out in a completely different way. While Unitree focuses on balance and recovery, Headform built a humanoid head so expressive it startles people who see it in action. The head glances around with curiosity, blinks naturally, and carries facial expressions that feel unsettlingly real. Their philosophy is that meaningful human-robot interaction doesn't just come from speech or body language, but from those micro expressions in the face, moving eyes, subtle cues, synchronized speech that make you feel like something is actually paying attention to you. Their series is called Elf, and yes, they lean into that with designs featuring big ears and exaggerated features. Some models pack 30 degrees of freedom just in the face, controlled by high-dose bionic actuation and an advanced AI system that learns to express emotion naturally. Their latest model, Zuon, is a full-body figure with a static torso, but a head capable of a massive range of lifelike gaze, behaviors, and expressions. Another one, the Elf V1, doesn't just mimic expressions, but perceives, communicates, learns, and interacts with its environment. The secret sauce here is a custom brushless motor designed specifically for facial control. Quiet, lightweight, energy efficient, and responsive enough to replicate the tiny movements that humans rely on to judge emotion. The founder, Hong Huyu, is ambitious but grounded. He says in 10 years, robots will feel almost human to interact with, and in 20 years, they'll be able to walk and perform tasks just like us. But he's also realistic. Creating something truly identical to a human is insanely difficult. Meanwhile, another Chinese startup decided to go completely savage in their testing. Skilled AI dropped a demo that shocked everyone. They strapped up a robot dog, fired up a chainsaw, and hacked off its legs. You'd think that would be the end of it. Instead, the machine just kept moving. Even with all 4 limbs gone, the AI brain adapted, hobbling around in ways that looked disturbing, but proved an important point. Skilled calls their system an omni-bodied robot brain. Instead of programming an AI to control one specific robot, they trained it across a simulated universe of 100,000 different robot bodies. That means the AI can't just memorize moves, it has to learn general strategies that work no matter the hardware. So whether it's a broken wheel, a missing limb, or even walking on stilts, the AI adjusts on the spot. Skilled says this hints at early intelligence in the physical world, and researchers see it as a preview of machines that could surpass both human planning and strength. What's unsettling is how casually we keep stress testing them. Kicks, chainsaws, chains, while knowing they might one day outthink us. Now let's shift to Shanghai, where Fourier Intelligence is showing off something that looks like a martial arts routine in robot form. Their N1 humanoid, also called Nexus 1, is a smaller, lighter platform that just nailed a full cartwheel and a 360-degree jump spin. It didn't just land the moves, it landed them clean, which is a huge deal in robotics. For context, Fourier's background is in rehabilitation robotics, but with their GR series, GR1, GR2, GR3, they moved into building full humanoids. The GR1, for example, weighed 55 kilograms with 44 degrees of freedom, while the GR3 leaned more toward companionship roles. The N1, though, is a real shift. It stands 1.3 meters tall, weighs 38 kilograms, made from aluminum alloy and engineering plastics. It can sprint up to 3.5 meters per second and run for more than 2 hours on a single charge. What makes it especially interesting is the open source philosophy behind it. Fourier provides the blueprints, software, control systems, and even the bill of materials. Universities, labs, and hobbyists can get self-assembly kits or buy a ready-made version. They call it their Nexus, open source ecological matrix, essentially an ecosystem where anyone can build and experiment on the platform. The cartwheels and KungFu spins are obviously attention-grabbing, but they're also proof that the robot can handle complex dynamic forces, recover balance, and withstand high-stress movement without breaking. In the market, it positions itself right next to Unitree's lineup, the H1, the G1, the new $6,000 R1, and of course, Boston Dynamics Atlas, which pioneered backflips and parkour routines years ago. This AI powerhouse comes from a collaboration between UCL, Google DeepMind, and Intrinsic. The core tech combines reinforcement learning with graph neural networks, which basically means it can learn by doing, and fast. Instead of humans spending days or even weeks programming every single move to avoid collisions and optimize tasks, RoboBallet does it in seconds. It's been tested with 8 robotic arms, handling up to 40 tasks simultaneously, and still not missing a beat. What's wild is that it doesn't just memorize how to do one job. RoboBallet learns general rules for coordination, which means it can instantly adapt to new factory layouts or sudden changes. Let's say one robot malfunctions or an obstacle shows up out of nowhere. RoboBallet replans everything on the fly. We're talking hundreds of times faster than real time. It's not just planning where each arm goes, it's making sure they all work together like a well-rehearsed performance. This isn't just theory. The team open-sourced RoboBallet and it's already being tested for welding, pick-and-place, and painting. The foundation is solid, even if it can't yet handle every type of robot or obstacle. As DeepMind's Matthew Lai put it, RoboBallet makes robots move in harmony, not just to avoid crashes, but to work faster and safer together. Now that robots can move together like dancers, here's the twist. Some of them are actually learning to play sports. A quadruped robot called Animal just learned how to play badminton. Not badly either. It's good enough to keep up a 10-shot rally with a human opponent. This isn't a joke, it's a real research project out of ETH Zurich. Using reinforcement learning and a pretty advanced visual system, Animal is already known for navigating rough terrains and climbing rocks. But now it's on the badminton court, with a racket in its robotic arm and 2 cameras tracking the shuttlecock in real time. It's not just reacting, it's predicting where that thing's going to land, adjusting its stance, and swinging like a toddler with surprising coordination. The robot weighs about 50 kilograms, stands at half a meter, and balances like a champ, even when lunging sideways to return a shot. The challenge wasn't just hitting the shuttlecock, it was doing it while staying upright and moving fast. The team trained it in simulation, where it played thousands of virtual rallies to get the technique just right before ever touching a real racket. It's fascinating how the same tech that helps Animal stay steady on rocky terrain during industrial inspections is now helping it plan footwork and racket swings. And this isn't just a party trick, it opens up real questions about how legged robots can function in fast, unpredictable environments, not just in factories, but in sports, entertainment, maybe even rehabilitation. Still, at $150,000 per unit, this one won't be showing up at your local gym anytime soon. But for elite training centers or labs looking to push the boundaries of what quadrupeds can do, this is just the beginning. Meanwhile, beneath the ocean, things are getting even more intense. Australia just went all in on autonomous submarines. They're called ghost sharks. Extra large, AI-powered undersea drones, and the government is spending 1.7 billion Australian dollars to build dozens of them with a United States partner, Anduril Industries.
Ghost Shark complements it. Ghost Shark operates in conjunction with it. That's the point that I made up front. And it also works in conjunction with our surface fleet. And what is clear is that going forward, nations will need to have an autonomous underwater military capability, and that's what Ghost Shark represents. But we will also need very much a long-range capable submarine in the future, and I'm really confident that that's what we are developing under the banner of AUKUS by providing Australia with that capability.
These things are huge, extra large autonomous undersea vehicles that don't need a crew, don't need to surface, and can carry out surveillance or even strike missions deep into contested waters. What's wild is that Australia took this from concept to fleet-ready production in just 3 years. That's insanely fast for military tech. Nuclear subs take decades. Ghost Shark? It's hitting the water in January 2026. They're built for range, stealth, and intelligence. Capable of launching from ships or coastlines, they can perform long-duration patrols across millions of square kilometers. Anduril co-developed it with the Royal Australian Navy in a kind of experimental defense partnership where both sides took risks to get this into service fast. Now, a lot of the details are classified. We don't know the exact number or even the full capabilities. But what's clear is that these drones are part of a larger geopolitical shift. Australia is reacting directly to China's growing naval presence in its region. Ghost Shark offers coastal defense, domain awareness, and even the potential for deterrence without putting human lives on the line. And unlike the $368 billion nuclear subdeal under AUKUS, Ghost Shark is relatively affordable and already operational. The government even mentioned the possibility of exporting these to allies, so we're not just looking at a national defense tool. This could be the prototype for a new class of AI-powered naval dominance. Back on land, South Korea is playing a different kind of long game. Earlier this year, they launched the K-Humanoid Alliance. It's not just another robotics program, it's a full-scale, government-backed push to become a global leader in humanoid robots by 2030. Over 40 companies, universities, and research institutes are in this thing, including Samsung, LG, KAIST, and Rainbow Robotics. They've already pooled over $1 trillion, around $750 million for this initiative. Their plan? Build humanoid robots with world-beating specs. We're talking under 60 kilograms, over 50 joints, a payload capacity above 20 kilograms, and speeds over 2.5 meters per second. The alliance is split into two big focuses: hardware and AI. The AI team, led by Seoul National University, is working on a foundational model that can handle vision, hearing, motion planning, and real-time sensing. Think of it as the brain. Meanwhile, hardware teams like HD Hyundai and Doosan Robotics are handling the body, high-performance joints, sensors, and power system. And yes, they're also developing specialized solid-state batteries and custom AI chips to keep these bots running safely and efficiently. The entire structure of this initiative is built around industry, academia, government collaboration. South Korea doesn't just want humanoids, they want to set the standards for the next global wave of robotics, especially as the humanoid sector is expected to grow from 1.5 billion now to 38 billion by 2035. So the competition is heating up. China is racing forward. The United States has Figure, Tesla, Apptronic, and now South Korea wants to be right there, if not leading. But let's zoom out, way out, to Mars. There's a new conversation happening in space circles, and it's not about sending more humans, it's about replacing them. Scientists and engineers are seriously considering artificial astronauts, robots with human-like bodies and minds, on future missions to the moon, Mars, and beyond. One reason is simple: survival. Humans are fragile, expensive to support, and limited by biology. Robots don't need oxygen, food, or sleep. They don't suffer from radiation, and they don't get homesick. With reinforcement learning in AGI or even ASI further down the line, these androids could plan, adapt, and execute space missions better than humans ever could. NASA's already tested humanoid prototypes like Valkyrie and Robonaut, and Elon Musk has talked openly about sending Tesla's Optimus robot to Mars in 2026 ahead of the first human missions, not as cargo loaders, but as real explorers. Meanwhile, planetary scientists like Pascal Lee are envisioning even more advanced super astronauts. These would be androids with artificial superintelligence, capable of safeguarding human DNA on interstellar journeys. Not just tools, but full-on successors. As Lee puts it, we'll start seeing these machines not as products, but as our offspring, extensions of ourselves into the cosmos. That's it for now. If you want more humanoids, AI, and next-gen robotics, hit subscribe and stick around. Big stuff is coming.